Okay, we're in section 16 of the notes. We're going to do these the examples now. I want to point out doing the examples, there's basically two limits that you should be able to conjure up as you're doing these examples. And that's going to be this one over here. That's the limit as h goes to 0 of sine h over h is equal to 1. And the other one is the limit as h goes to 0 of cosine h minus 1 over h is equal to 0. So those are two you probably should have, at the tip of your tongue as you're doing these problems, if you need them. I'm not going to say you need them, but if you need them. So let me go to the whiteboard. And as I go to the whiteboard, I'm hoping that you have your paper and pencil handy and you're willing to try on your own. Let me do that. In other words, you're going to be taking notes. So let's take a look. And what am I seeing over here? Example. And what they say is that you should be able to prove using the definition of the derivative that this is equal to minus sine of x. So let's go through that. So let's see if we understand what that means. So the derivative of cosine x with respect to x. Well, the definition, I'll write this down for you. Limit h goes to 0. Let's write this down, right? H cosine x plus h minus cosine of x. I gotta be real careful now. All right, so what do you get over here? Limit h goes to 0. I'm going to remember what I did in Math 120. I knew I'd take this, the cosine of a plus b, so it's really just the same thing. So cosine x times cosine h, and then it's going to be minus sine x sine h minus cosine x. All right, I got to keep working on it, and it's going to be equal the limit h goes to 0. I want to point out what I'm looking at. I'm looking at this first, the guy in the middle. I'm going to kind of split this thing up. So it's going to be minus sine x times sine h. And I'll put the h over there. Let's do the next guy. And, so what do you mean the next guy? It's this guy over here. I notice that cosine x is common to those two terms. All right. So I put that down for you. And I'm going to write down, let's see. I guess I could factor out cosine x, right? Let's be careful. And what would you get over there? You would get 1 minus cosine h over h. All right, now remember, I said there's two limits you need to be able to remember. And this is one, and that's the other. All right. Now, granted, I'd say it's a little different, really the same thing, by the way. I'm seeing the sine h over h. I know that's 1. And, maybe I shouldn't have factored out minus cosine x to make it look exactly like that one. But I hope you realize it's really the same limit. All right. So what do you get over there? Well, it's going to be, the first one's going to be just simply minus sine x times 1. And the second one's going to be minus cosine x times 0. Let me write that down for you. Minus sine x times 1 minus cosine x times 0. All right. What do you get over there? Minus sine x. Is that what they said? They sure did. So the way they say, you should be able to prove using the definition of derivative. We just did that. We proved it. Let's go to number 2. Oh, by the way, the work is down there for you. All right. Let's go to number 2. And number 2 says using rules, you should be able to show that. But let me talk about what rules are. They're not asking for definition, by the way. They're saying the rules. So let's write down what they're saying we should be able to do. We should be able to take the derivative of the tangent x with respect to x. And we should be able to, using rules, show it's equal to the secant squared x. I want to tell you there's only 2 things you need to remember. And the 2 things that you need to remember is you need to remember the derivative of the sine x with respect to x is cosine x. You need to remember that. And you need to remember that the derivative of cosine x with respect to x is minus sine x. From that, the other ones are really easy to do. So let's write this one down over here using just what I know. So what's tangent x? Well, I don't know tangent x, but I do know sine and cosine. So d dx, tangent is going to be sine x over cosine x. Now I'm going to use rules, and the rule I'm going to be using is the quotient rule. So cosine squared, cosine x times, which of sine is cosine? Minus the top, which is sine x. What's your cosine? I should know that, right? It's minus sine x, so plus sine x now. What do you get here? Let's go through it. You get cosine squared x plus sine squared x over cosine squared x. What does that give you? 1 over cosine squared x, which we know to be secant squared x. Is that what we're supposed to do? Yes, that's what we're supposed to do. So number 2 is done. Let's go to number 3. And number 3 says, using what you know, rules, and the derivative of sines and cosines, you'll be able to get this one over here. Well, I don't know. Let's see if we can do it. So they're saying that I should be able to take the derivative. Let me write this over here. The derivative of the cosecant. And I should be able to get that over there. Well, I don't know if I can do that. Let's see if we can do it. So what do you get over here? Well, it's going to be, whoops, sorry about that. I'm at a two-flown refraction bar. D dx. Well, I don't know about the cosecant, but I do know it's related to sine. Let's write this down. And to write this down is to understand that it's really just a quotient rule. Square the bottom. Bring the bottom to the top. The top is 0 minus the top times the bottom, which is cosine. All right. So what do you get over here? Well, let's write it down. You get on top, you get minus cosine x. And on bottom, you get sine x times sine x, which I recognize to be minus the cotangent of x times 1 over sine is cosecant of x. Is that what they said it was? Let's go back over here. And they did. They said minus cotangent times cosecant. I got that one done. Right now, someone says, I want to memorize that. We don't mind you memorizing anything, by the way. Be my guest. All right. Let's do number 4. Looks relatively simple. So d dx, I'm going to relate it back to what I do know. This is secant x. I don't know secant x, but I do know this is related to 1 over cosine x. Let's go through it. That's going to be square the bottom, bring the bottom to the top. Derivative of top is 0 minus the top times the derivative of the bottom, which is going to be minus sine x. I'll put that over here. What do you get? Sine x, cosine x, cosine x. Sine over cosine is tangent x, and whatever cosine is secant x. I'm saying that's the answer. Let's see what they said it was. Miracle. We got the same answer. Let's go to number 5. The question is, I put 5 down. Yeah, I did. All right. Really kind of same thing. And again, somebody says, I want to memorize these guys. We're not opposed to it, by the way. But d dx of the cotangent x, well, I'm going to write that as d dx in terms of functions that I do know, which are sines and cosines. So it's going to be cosine x. Whoops, sorry about that. Cosine x. I did it again. Cosine x over sine x. We'll look at the key later. How do I do that? Quotient rule. Sine squared. That's sine x. Derivative of cosine is minus sine x. Minus cosine x. Derivative of sine x, which is cosine x. What do you get over here? Minus sine squared. Minus cosine squared. Sine squared x. Let's keep going. I'm going to factor out a -1. So it's going to be sine squared plus cosine squared over sine squared. What does that give me? -1 over sine squared x, which is minus cosecant squared x. Again, some of these things you can probably do in your head, but I'm not going to recommend it. I'm going to recommend that you go through that and you write it down. Now, on exams, you can remember something, good for you. If you can't remember something, well, who cares? Derive it then. All right, I got to do this one over here now. So it says find an equation of a tangent line to the curve y equals secant x minus 2 cosine x at the point pi over 3, 1. Well, I'm kind of retentive. I'm going to make sure that's on that thing because maybe they're giving me a really tough problem here I can't figure out. But anyway, what's y? I think y is 1. Now pi over 3, I want to remind you pi over 3, right? Pi over 3, 180 degrees over pi. That's 60 degrees, right? I'm going to draw my little picture over here, 60 degree. This is something you learn in trigonometry. And what's the secant of that? It's going to be 2. Minus 2. What's the cosine? 1/2. And what do you get over there? Well, 2 minus 1. Gee, that worked out beautifully. So I know the equation now. What's the equation going to look like? Y minus y1, which is 1, equals m tangent. I don't know that yet. And then what do you get? X minus pi over 3. What I have to do, though, is get the tangent. So to do that, what I have to do is I have to get dy dx. And after I get that, I have to evaluate that the value where x is pi over 3. And this is going to be the m tangent for this particular problem. So what's my issue right now? My issue is getting the derivative. So as I can't remember. That's fine. So you derive it. Let's put this over here. So if y is equal to secant x minus 2 cosine x, I'm going to say maybe something you can't remember, which is a secant, but you should be able to derivative of cosine. And what's that going to be? Minus sine. So it's going to be plus 2 sine x. I just did this guy over here. But let's say you're in an exam and say, I can't remember it. It's been such a long time, I can't get it. I'm going to say, write it down. What is it going to be? 1 over cosine. What I'm going to do, differentiate that with respect to x. Let me just quickly go through that for you. That's cosine squared. Cosine x times derivative top is 0, minus the top times derivative of the bottom, which is sine. So what do you get over there? Well, I'm sorry, that's minus sine. Sorry about that. What do you get over there? You get sine x over cosine squared x. And what's that going to give you? Well, that's going to be sine over cosine, which is tangent x times secant x. Well, let me write that down. Tan x times secant x. I got to do y prime at what number? Pi over 3. What's a tangent of 60 degrees? Root 3 over 2. What's the secant? 2 plus 2. What's the sine? Root 3 over 2. See if we can do that. I'm sorry, I said root 3 over 2. It's not true for the tangent. I got to erase that. And I don't know why I said that. Let me point out tangent. We're looking at this picture over here. That's root 3 over 1, right? So what do you get over here? 2 root 3 plus root 3, which is 3 root 3. So now I got the slope. Let's go back over here. We'll check the key later. Y minus 1, 3 root 3 times x minus pi over 3. Let's look at the answer. See how we did. Y minus 1, 3 root 3, x minus pi over 3. All right, that looks pretty good. Let's do number 7. Number 7, a little more difficult because a lot of things are going on. I'll write down for you. What's y? Y is x plus sine x. And the bottom is x squared plus cosine x. Dy dx. You could also write down y prime if you want. I'm going to square the bottom, x squared plus cosine x squared. Bring the bottom to the top. Time derivative top, which would be 1 plus cosine x minus the top times the derivative of the bottom, and that's going to be 2x minus sine x. If this is an exam question, I would give this credit, and I would be looking at it. I noticed they simplified it, so I'm gonna simplify it too then. All right, let's see if we can do that. All right, you might say it's too much work. I couldn't deny it, but I got to try it. I'm gonna try to match their answer. And what do you get there? You get x squared using the distributive property multiplication. X squared plus x squared cosine x plus cosine x plus cosine squared x. Next one's gonna be tough. It's a subtraction problem, right? So let's write this down. Minus 2x squared. Let's see, plus x sine x minus 2x sine x plus sine squared. Yeah, I know it's work. We're encouraging work though. I hate to tell you that, we really do. And let's take a look at that. X squared plus cosine x squared. Let's take a look, be very careful now. So I notice I got this and I got this, which is 1. I'll put that down. And then I notice I got this and I got that, which is minus x squared. And then what do I have? Now I'm looking at a bunch of things left over here, right? So I'm going to say, x sine x, I'm seeing that. And then I'm seeing, I'm sorry, minus x sine x. I'm sorry about that because it's over there too. I got to erase that now. And let me see what we have left now. We have this thing left over here, right? So what comes out of there? Cosine x. And you get x squared plus 1. Let's take a look at the answer though and see if we got it. And again, someone says, I don't want to do all that work. You don't have to. I'll take this as an answer. So let's see if we got it. 1 minus x squared minus x sine x. X squared plus 1 times cosine x. Miracle. We got it. That's good, Neil. All right. I realize a lot of students look at when I do number 8 and they say they don't want to do it that way. And the thing is, we're trying to, encourage you to think about what you have over here. And, someone says, well, I'll just remember the answer and that's good by May. It's not. You don't want to be memorizing things because you can get tripped up in the long run. So what I want to do is I want to say it's related to things I've seen before. So write this over here, limit x goes to 0. I'm going to put down sine 3x times sine 3x over x over x. All right. I want to point out, we do know a limit that looks sort of like this one over here. The limit that we know is h goes to 0, sine h over h. And what I'm going to claim over here is this limit needs to be understood. What does it say? H is going to 0. Basically, it says the argument for the sine h has to be the same thing as down over here. Well, I'm noticing this over here is not what's there. So I got to put that down now. I'm going to be very careful about this. This is not the same limit though. And why is that? Well, if you looked at it, the top's the same, but the bottom now is 9x squared. So what I need to multiply is 9 over 1. This and this are identical. What's this guy's limit? Well, they're both going towards 0 at the same rate. So it's going to be 1. These are both going towards 0. When I say that 3x, 3x going to 0 at the same rate, that's 1. So what's the limit? The limit's 9. Let's go to the next page. By the way, this would be the work that we would like to see from you. All right, let's look at the limit, see what happens. Well, this doesn't look bad, by the way. I'll tell you why. I think I can do the limit. If x goes towards 0, the top goes towards 1. That's not an issue at all. If x goes towards 0, the bottom goes towards 0 minus 1. So the top goes towards 1, the bottom goes towards minus 1. What do you get? Minus 1. All right. No problems there. All right, let's look at number 10. And number 10 doesn't look good. It looks like it's all over the place, right? So it says suppose that f pi over 3 is 4. I can go with that. And that f prime pi over 3 is minus 2. And then to say g of x equals f of x sine x. Let me write this down for you. Well, what they're asking for is they're asking for this. Well, I'm going to write this down first. I'm going to write down g prime first. That's g. How do I do that? I guess we do f of x, right? Times the derivative of sine, which is cosine, plus the derivative of f, which is f prime, times sine x. And they want to know what g prime is. Let me make sure that pi over 3, right? That's going to be f of pi over 3. This is not a memorization skill. This is just simply a reading skill. Cosine of pi over 3 plus f prime pi over 3 times the sine of pi over 3. Well, I think we did a triangle before like this, right? And pi over 3 is 60 degrees. So this is 6 degrees over here. This is going to be root 3, 2, 1. Let's write this down. Do you know what f of pi over 3 is? I can't remember. It's 4. Do you know the cosine of pi over 3? I do. It's a half. Do you know f prime pi over 3? Can't remember, but I'll look it up. It's minus 2. Do you know sine of pi over 3? Yes, it's root 3 over 2. Let's do this. You get 2 minus root 3. Let's look at the k, see how we did. And I'm seeing it. Now let's do the next one. What's the next one going to be? H of x. Yep, I know it's tough. What's h of x? It's cosine x divided by f of x. Well, I need to get its derivative. And what are you going to go over here? H prime. Yeah, it's going to be work. I have to square the bottom. Bring the bottom to the top. Times the derivative top, which is minus sine x. Minus the top, which is cosine x. Times the derivative of the bottom, which is f prime. What do they want me to do? And again, it's not a memorization skill. It's reading at this point. They want to do h prime of pi over 3. Well, I'm going to write it down. And then we'll put the numbers in later. And again, I hope you're not trying to memorize too much. Sorry about that. All right. Do you know what f of pi over 3 is? It's 4. I'm going to put that down now. All right, do you know the sine of pi over 3? Well, we just did that before. I hope you can remember. That's root 3 over 2. Minus, do you know the cosine of pi over 3? Again, we just did it before. It's 1/2. Do you remember what f prime of pi over 3 is? No, not important. What is it? It's going to be minus 2. So I'll write that down for you. You got to do the arithmetic. The bottom is 16. What do you get on top? You would get minus 2 root 3s. And that's going to be plus 1 now, right? So let's write that down. You're going to get 1 minus 2 root 3s over 16. You're probably going to hear me say this a billion times. Hopefully you're sick and tired of hearing it. Mistakes happen. I'm going to see if I got the right answer though. And what's the right answer? 1 minus 2 root 3 over 16. We did it right. All right, let's do number 11 now. 11 looks really strange. And they want f prime and f double prime. Let's write this down. So f, and that's a beta, right? That's my attempt at putting the beta down. All right, so let's put f prime down. Now this is the derivative of f with respect to that beta. So first function, beta, times derivative of the second function, which is cosine beta, plus the derivative of beta is like a variable 1 times sine beta. So I'm going to say that's f prime. I'm going to go back over here and see how we did. Well, they wrote a different order, but sine beta, beta plus cosine beta. We did pretty good there. Now what I'm going to do, f double prime. All right, let's go for it. Derivative of beta is 1, so cosine beta minus beta sine beta. I just did that over there. And then what do you get over there? Well, derivative of cosine, sine is cosine, right? So what do you get over here? 2 cosine beta minus beta sine beta. Let's see how we did. Again, if I made a mistake, I'll correct myself. So 2 cosine beta minus beta sine beta. Looking good. All right, what do you have to do now? You're going to have to do this. You need to practice. You need to try. It isn't just watching someone, it's trying to see if you can do what they've done, right? It's almost like you're watching someone skateboard saying, can I try? Well, you're going to be surprised when you start to try something, you're going to fall down and you get yourself back up and try again. Keep trying until you get it. However, if you need assistance, please come by during office hours and I'll be more than happy to help you. Thank you.